Okay, so far we've covered and what an overview of cellular respiration looks like, and that involves four main stages. And now we're going to look at each stage individually in a little bit more detail. And I did put something in the news that said that the stuff we're about to learn, it's going to seem a little overwhelming because there's a lot of new molecules we've never talked about, a lot of chemical formulas and structures that we've never seen before. And I don't want you to feel overwhelmed in the sense that you feel like you have to remember every single thing you're looking at. And that's the purpose of these videos, is I'm going to go through and just highlight sort of the big ideas from each stage, which you should know. If you continue in university studying cellular biology, you will eventually get to the point where you do have to know everything that you're looking at. But let's save that for later. Right now, we're just kind of learning an overview of each stage and sort of the important molecules that are key players throughout and sort of the big things that come in and go for each stage. So stage one is called glycolysis, and it starts with a 6-carbon glucose, and it produces, so here's two things you definitely should know. Starting materials for glycolysis. Glucose is your starting material for glycolysis. End product, a molecule called pyruvate, and it's a 3-carbon molecule. So you can already see right now we're starting with a 6-carbon molecule, and we're ending up with 2 3-carbon molecules. So that makes sense, right? The carbons we started with are the full carbons that we finish with. And you'll see that there's a spot for everything that gets broken down from glucose. Second main thing that you should know about glycolysis is that it occurs in the cytoplasm. And the third main thing is that it can occur with or without oxygen. So we're going to look at a couple of different diagrams, and I left you guys with a diagram that was a fill-in-the-blank diagram, which is a little bit more detailed than what you see here, but this is just to sort of give you an idea of the big ideas, and these are always things you can come back to when you need to refresh your memory about the overall things that happen. So here's our glucose, our 6-carbon glucose molecule, and it's going to enter this cycle. So we don't see all the steps in this diagram, but we don't want to. We just want to say, okay, along the way from start to finish of this process, what happens is we have the input of 2 ATP molecules that get converted to ADP. And this goes back to that first note that I gave you. When we remove one of the phosphates from ATP, we're releasing energy in the process by breaking that bond. Okay. Second thing that happens is we require 2 NAD molecules, and these are basically coenzymes. They call these coenzymes. And these coenzymes, we haven't talked about these yet, and I'll show you basically what their purpose is once we get into the process a little bit more detail. But what you should know is that it's an important coenzyme that transfers electrons from glycolysis to later stages in cellular respiration. And these are high energy electrons that are taken from this stage that are brought to a later stage to help other processes go on. And so those electrons are carried in a hydrogen atom. So remember, your hydrogen atom has 1 electron, 1 proton, and when we're adding those on, they become carriers and potential transported to another stage, which can then deliver those electrons to another stage. Okay, and then finally, at the end, we end up also needing 4 ADP molecules that get phosphates reattached to them. So we're making more ATP. So yes, we're using up ATP in this process. We're using 2, and we're producing 4. So really, there's a net gain of 2 ATPs for every time glycolysis process happens. And in the end, we end up with 2 3-carbon molecules that are called pyruvate. So again, just coming back to this diagram, I said this is a great one to come back to as we work through the unit to kind of remember where and how things are related and where it happens. So we're at glycolysis, first stage, we're in the cytoplasm, and we're making some ATP, and then we're going to produce a product that will then head into the mitochondria for stage 2. Okay, so here's the diagram that I left you guys with yesterday or the day before. And it was to you guys to use your textbook and try and fill in the missing information. And I know our textbook, it might not be word for word what you see in your textbook, but most of it's there, and whatever isn't, I'm just going to highlight and go through right now. So During the first 4 steps of glycolysis, 2 phosphates are transferred to glucose. These come from ATP, which is converted to ADP. The end product is this. So here I'm going to highlight what we should know here. We're starting off with this glucose molecule. Here's what glucose looks like. Do you need to memorize this structure and be able to draw it? No, you don't, but you should know that it is a 6-carbon sugar and it has hydrogens and oxygens attached to it in a specific ratio. Here's what you also should know, that in anytime you see this structure, this is what this is telling us, and if you follow the arrows, that ATP is coming in and it's being split. So here's what's coming in, here's what's exiting. So our reactants of a reaction and a products. And if you can see what's happening, anytime ATP is split into its individual phosphate and then left with ADP, that phosphate's going to get used somewhere. And I'm highlighting here in my colors, which you might want to do on your sheets, that that free phosphate gets attached to glucose. Okay, and so if you think about it, we start with glucose and we attach a phosphate to its 6th carbon. That's why this name changes. It becomes glucose 6-phosphate, and that little 6 means that our phosphate is attached to the 6th carbon. The other thing that you might want explaining as well is, why is this a PI and not just a P? In chemistry, it's considered an inorganic item. And so this just stands for inorganic phosphate. And you don't need to know any more than that, difference between organic and inorganic, but that's what that little I stands for. Okay, and then it happens again. And so if that happens again, we have another free phosphate to go somewhere else. And what happens is it attaches onto the 1st carbon of the glucose molecule. And now what happens is our whole name changes to fructose 1,6, where each of the phosphates are, biphosphate, bi meaning 2 phosphates. Okay, and the other thing, let's just highlight here. So what you should know here is what happens in the first 2 steps of glycolysis. Not the individual structures and makeup, but you should be able to describe in words that we have glucose, and in the first few steps, we're adding 2 phosphates to glucose to make this. So you should know the name of this, just the name and how it got formed, and it got formed because we started with glucose and we added 2 phosphates to it. Okay? Okay, next step, and the summary is right over here. Fructose 1,6 bisphosphate, or sometimes you'll see it called bisphosphate, but biphosphate is how I remember it. It gets split into 2 fragments. DHAP stands for a really long name that you do not need to know. It's called dihydroxyacetone phosphate, and another one, glyceraldehyde 3-phosphate. All you need to know at this point is that it splits into 2 3-carbon molecules. So a 6-carbon molecule just split individually into 2 different molecules that each have 3 carbons. You don't need to know these names. Okay? And so now that we have 2 individual 3-carbon molecules, this pathway actually happens. I'm going to uncover all of it. It actually occurs twice. Okay, so we're only showing the flow of it happening once, but it actually occurs for each of the 3 carbons. And that's why what you see happening here, you have to multiply it by 2 to get the full amounts of everything that came out. So here's one example of the pathway happening once. So one of our 3-carbon sugars here, these are, remember I just said coenzymes, they're used as energy carriers. And so anytime you see an arrow coming in and back out, at the opposite end of the arrowhead is what you start with. At the end of the arrowhead is what you finish with. We're starting with NAD, and we end up with NADH. If you remember from our first unit, we talked about redox reactions and the transfer of electrons, and if we have oxidation or reduction. If you think about NAD plus is getting an electron from this hydrogen, so it's gaining an electron. Remember that gaining electron means reduction. Loss of electron means oxidation. Gaining of an electron means reduction. So what's happening here is the reduction of NAD releases energy so that the next step can happen, so that phosphate can join on to this glyceraldehyde 3-phosphate. So 2 things happen in this first step. We reduce NAD, and we add a phosphate onto our glyceraldehyde 3-phosphate. Okay, and if we're adding a phosphate on, okay, so they're on these 3 carbon sugars just momentarily. So remember, what's happening through here is also happening to this guy. So we're just showing it once. It's momentarily on there to be able to be transferred back to an ADP molecule. So you might be wondering, where are these ADPs and ATPs all coming from in the first place? They exist in our body and they're recycled. So they're all going to be there once this whole entire process of cellular respiration happens. They're floating around waiting to be reused. So this phosphate then is released and it attaches onto an ADP in order to create another ATP. Okay, and that's, remember, energy for our body. And then a couple more steps. You don't need to know the details of what's happening in these steps. However, I am going to go back and just highlight. So you should know when ADP is used up and or when it's formed, at what steps here. Okay, so I highlighted that these kind of first 4 steps are important. Only in what happens, not in the actual structures themselves. Once things split, you should know what the purpose of NAD to NADH is, the reduction here. And again, here we've got a production of ATP, so that's important. And our final step, again, phosphates coming off and creating ATP. So in these last 4 steps, we end up with a phosphate, an ATP produced here and an ATP produced here. And in the conversion and rearrangement of all of these molecules, the only other thing you should know is what our final product is, and it's a pyruvate. It's a 3-carbon sugar, or a 3-carbon molecule. So that really sums up glycolysis in detail. And like I said, if you carry on continuing to study science, you will eventually need to know what these structures are and how to draw them out. But right now, I'm highlighting the areas and things. So there's a series of a few events you should understand in the beginning, which I've highlighted, that we start with glucose, we're taking ADP, converting ADP to PI, and we're using those phosphates and attaching them to glucose. When we attach them to glucose, their name changes. And we end up with ultimately this sugar that has 2 phosphates attached to it that then gets split. We use these energy carrier molecules to help attach some free-floating phosphates onto these 3-carbon sugars, so now they have 2 again. And then one comes back off to make ATP, another one comes back off to make another ATP. And so again, if you go back to that original, I can do that, the original summation I showed you, you can see now how we need a net input of 2 ATP for glycolysis. And you might think, well, wait a minute, we need ATP for our body, but this is actually helping this process to produce 4 more. So yes, we're using up 2, but we produce 4, so we actually have a net gain of 2 ATP by the end of glycolysis. I'm going to just show you one last thing. This you should know, and this is just an overall chemical reaction showing all of the things, the starting materials that we start with and the things that we finish with. Okay, so we start off with the glucose, 2 ADP and 2 PI. We need 2 NADH or NAD plus molecules, and in the end we end up forming 2 pyruvate. These are our 3-carbon sugars. We end up with a net gain of 2 ATP. So this is sort of a net chemical reaction. It's not showing everything going in and everything coming out, just the net of what goes in, net of what goes out. And then we end up with 2 NADHs, okay? And these, remember I told you, they're going to come into play or be more important when we get into later stages of cellular respiration. So don't worry about these too much right now. Right now, we just saw that when they add hydrogens and take hydrogens away, we end up with some energy to be able to help reactions happen. And that's it for glycolysis.